Planes are two-dimensional sheets that they have length and width. Think of a wall as a plane. Think about 1,000 paint specks on the wall. Each of those speckles is a point on the plane. Think of 10,000 times 10,000 more specks of paint on the wall. Soon the entire wall would be made up of specks of paint. That is what a plane is, a sheet of points that it has length and width but no thickness. Planes do not arid. Planes do not end as walls end. Planes are infinite and continue on through space. There is nothing to stop a plane. Not only are there the planes that not be imagined, such as walls, ceilings, floors, etc. Also, there are planes not on top of other planes, in front of planes, intersecting with other planes. Planes run through each other all the time, just as lines cross, so do planes. All of the points that lie in a plane are said to be coplanar. So all of the points on the wall are coplanar, and all of the lines, line segments, and rays that also lie completely within that plane also are coplanar. Those that do not lie within the same plane are said to be non-coplanar. Traversal exterior and interior regions on planes. There are lines. Those lines are intersections by traversal. Traversals are lines that intersect two other lines in two distinct points. The lines need not to be parallel. When a traversal intersects the two lines, a whole series of angle pairs are made that relate directly to the discussion of the lines by traversal. Exterior, interior region, traversal, exterior region. There are a number of definitions needed at this time. Alternate interior angles to angles that are inside the lines of on either side of the traversal. In the figure, angles A and B are one pair of alternate interior angles, and C and D are another pair. Alternate exterior angles to angles that are outside the lines on either side of the traversal. In the figure, angles A and B are one pair of alternate exterior angles, and C and D are another pair. Corresponding angles to angles that are the same but just shifted. That is, if one line were placed on top of the other line, the one angle would be on top of the other angle. In the figure, angles A and B are one pair of corresponding angles, and C and D, E and F, and G and H are three other pairs. And alternate interior, alternate exterior, and corresponding angles are instrumental in proving shapes to be congruent. A plane is a surface such as if any 2 points on the surface are connected by a line, all points of the line will lie on the surface. If points, lines, segments, etc. lie in the same plane, we call them coplanar. Similar points, lines, segments, etc., which do not all lie on the same plane are called non-coplanar. The point of intersection of a line and plane is called the foot of the line. Point A is the foot of the line in the figure. Parallel planes are planes that do not intersect as in the figure. Skew lines are two lines that are not coplanar. In particular, they neither intersect nor are they parallel. One example is shown in the figure. Postulates about planes. 2 postulate 5. 2 points determine a line. Postulate 6. 3 non-collinear points determine a plane. Postulate 7. If a line intersects a plane not contained it, then the intersection is exactly 1 point. Postulate 8. If 2 planes intersect, their intersection is exactly 1 point. Theorems about planes. Theorem 24. A line and a point not on the line determine a plane. Theorem 25. 2 intersecting lines determine a plane. Theorem 26. 2 parallel lines determine a plane. Theorem 27. If a line is perpendicular to 2 distinct lines that lie in a plane and that pass through its foot, then it's perpendicular to the plane. Theorem 28. If a plane intersects 2 parallel planes, the lines of intersection are parallel. Notes about planes. A line perpendicular to a plane is a line perpendicular to every line in the plane that passes through its foot. A line and a plane that do not intersect are parallel. And this concludes Geometry, Chapter 5, Parallel Lines and Related Figures.